Alright, so today I'm going to be solving this problem. This isn't really an informative video or tutorial, it's just kind of like a vlog or a blog of me just, learning pre-calculus, alright? So fair warning, you will not learn anything from this, right? Yeah, I am just teaching myself and kind of just trying to go through the processes myself, alright? Cool, so it's just going to be kind of like a video log of me just kind of showing my knowledge. Alright, so over here we're given a table. I will, however, talk about my experiences and my thought process and everything, so you could use that to your benefit if you want. So here's the table that we're given, right? This gives us all answers we need, or all outputs we need to a specific input in a function. Alright, so all the outputs that are related to an input we get in our table. Okay, I'm gonna go ahead and erase that because it's just gonna get all cluttered. Okay, so now this table shows us two functions, f and g, so we know it's function composition, right? Because it's two functions, right? And we are given this over here, right? This operator, or arithmetic operation, whatever you want to call it. And you'll see here it has this dot. This dot signifies composition, function composition, alright? But this whole syntax is kind of weird and kind of confusing. So a more easier way of recognizing this is simply that G's output becomes the input of F. And since the output is characterized as the function itself, right? And then the brackets of the input, right? We can think of it like this. This 12 becomes the input of function G, right? And then the output of function G becomes the input of function F. So it kind of works as kind of like a flow, right? So kind of like this. I did not want to highlight everything. Okay, there we go. So it kind of works like this. The 12 goes into G, right? And some magic happens and whatever, and we get an output. Boom. That output then goes into F. As simple as that. So the way that we would represent this more easily and more recognizably is through this way. It's going to be F, G, and 12. This represents the same flow that we were talking about from before, right? Because this has become the input for F, function F. So let's go ahead and solve this. Alright, again, I'm going to clear this up and let's get into it. Alright, so as I said, it's going to be F, G, and 12 because again 12 goes into F, F does some magic, and that output of that magical thing that it did becomes the input of F, and then F gives us whatever, which goes into here, right? So okay, so we're going to start off by finding the output of G, which is the input of F, right? So here's how it goes. We're going to first find, through this table that we have, we're going to find 12 in here, right? Because we're looking at the function G, right? Right? So because this is function G's table. Alright? So we're just going to try to look in X because X represents the input for 12 because that's what we're giving as an input for G. So that's over here. And if we cross-reference to see what the output would be, again, remember how I showed you the style of how outputs in functions are written, which is G, function and then input, like this, right? it's giving us a negative 8. So that means that the output for g of 12, function g of 12, is negative 8. Negative of 8. As simple as that, alright? So I'm going to go ahead and erase everything, and let's do this. Let's just evaluate this, right? Okay, cool. So again, we're going to start off just by writing f of g of 12, like so, right? Then we find the output of g of 12, which is through the table, which is negative 8, right? Now what we need to do is find the output when the function f has an input of negative 8, right? Because the output of function g becomes the input to function f. So if we cross-reference to our table here, right? In this case, this one, because this one serves for the function f, right? If we look over here, we'll see it's the first one, right? Because this is our input, this is our output. So when the input is negative 8, we get an output of negative 16. So it's just going to be, we get an output of positive 16. So the answer is just going to be 16 simply. Now if I go here, type in 16, you'll see we get it correct. Moving on. Raphael has a solar-powered video game console. Interesting. He saw and modeled the following relationships. So here are the input and outputs and their corresponding variables, right? Which of the two composed functions makes sense in this context? So for a composed function to make sense, right? For the composed function to make sense, what we need is the output of one function, right, being the same as the input of another function. Because that's the whole point of composition, right? You're taking the output of one function and making it the input of another function. So they have to share those two variables, right? They have to serve the same purpose. So let me go ahead and erase this. Let's look over here and just go kind of downwards, right? So we're going to start off with d of e of x, right? So if we look at function d, it gives us the output of hours of daylight. So this function in the end will give us hours of daylight. Okay? But if we look at the output that the function e of k is giving, right, which is here, right, because if you cross-reference it, I did not mean to pick that. Sorry, guys. Okay, so I guess I can't really go into the area where the answers are. Sorry about that. But if you cross-reference it to over here, right, this part, you'll see that it doesn't make any sense, right? Because the output for function e of k, right, e of k, the output for function e is amount of solar energy gained over the day. But the input that function d is taking is the time of year. So they both do not have the same input or output in this case. So we can go ahead and this is not cooperating with me at all. I hate technology sometimes. Sorry. Okay, yeah. So this is a no-go. Okay? Doesn't work. So answer A is not correct. Let's look at answer B. So it's gonna give us an output of the amount of solar energy gained over the day. Alright, so that's gonna be our final output. That's what it's gonna be. right? The final output is going to be amount of energy gained over the day, E of K, if you want to see the variable form. The input is D of X, right, which is hours of daylight. Now this makes sense because, again, the output of this, of function D, becomes the input of function E, and the output for function D is hours of daylight, and the input for function E is hours of daylight too. So function B would make sense. Alright, moving on to the next thing. And again, if this one makes sense, then there's no need to go to question D or even evaluate question D, because we know it'd be question D if question C is not correct, right? It's process of elimination, guys. Okay, so let's do this one now. I already kind of know that this one's not correct. It's going to be question D, because if we look here, this is taking, this function is taking, E is going to be taking the input of G of R, right? Now, G of R is how hours of video games Raphael can play, but E needs an input of needs an input of hours of daylight, right? Which G of R is not giving. It's giving hours of video games. It's not giving hours of daylight. So that means that it has to be D.